everybody. So now we're ready to get started learning how to program in Python 3. Every computer program is some sort of input into your computing device. We're going to process that input and we're going to output the result of our processes. And what is it that we're inputting, processing, and outputting? Data. So we need to be able to represent data in our computer programs, and we do that with variables. So we have to give our variables some sort of name, and you can think of the name as a label. It's an address. It's what allows us to retrieve the value of that variable. So let's say I have a variable that I'm going to name age. And in Python 3, we use the equal symbols to assign that variable name a value. So let's say our age is 19. So now I have assigned the variable age, that's the label, that's the name on the left hand of the equal sign, with the value 19 on the right hand side of the equal sign. And where is it that we're storing this? Well, everything on your computer that is running is stored in our RAM, random access memory. So we pull data and information programs from hard storage. So this could be a hard drive, a USB key from the cloud. And we're going to find a place to store that on our RAM. And we'll talk a little bit more about how that's done when we talk about binary and hexadecimal. But your whole computer, a digital computer, is really just a bunch of circuits. The circuits are turning on and off, so electricity is running or it's not running. And that pattern, those patterns of on and off signals essentially is what the computer sees, and that's how we store information. So back to our variables. So we have to have different types of variables because we have different types of data. So 19 is a number. It's a whole number, so we call that an integer. So this is the int data type in Python. If we decided to do something like a decimal number, so we could say my age is 19.5, so we have some sort of fractional component. This is a different data type called a float. So these are stored differently inside of RAM. The different amounts of space are allocated. The way that we have to store these zeros and ones, these on and off signals, has to be different to be able to compensate, to be able to store this 0.5 correctly. So anytime we want to have a whole number, this is going to be an integer data type. Anytime we need to have a decimal component on our data type, that's going to be a float. But what if we just want a string of characters? So we're not going to calculate anything. So with this integer, I could add a year to that and make that 20. So I could say something like age, the name of my variable, is equal to what is stored already in age plus 1, and now age is 20. So if we could look on our RAM, and it's not exactly stored like this, this is just sort of a representation, but we've got the label of age, and it started out with the value of 19, but now the value of 20 is stored there. So we can do calculations, we can do mathematical calculations with integers and with floats, but strings, on the other hand, are just characters. We don't add and subtract these. They can include numbers, but we're not going to do calculations with these. To show that this is a string data type, we call these string literals because it's literally whatever is inside the quote is exactly what gets stored inside of memory. So we could store my name, Hillary. So now this string, if we could look inside of RAM right in here, Hillary gets stored right in there with the label name. And I could throw in a 1 there. And that's just the label, the letter, the string, the character of 1, not the number. I can't add and subtract anything with that. It's just the character. So we could have other things in there. I could put an exclamation point. Again, that just gets stored right in there. It's just simply the string of characters. These are the main basic data types we're going to be using. In addition, the other basic data type is going to be what's called a Boolean data type. And this is basically true or false. These are the only two values a Boolean can have. So I could have something like, maybe the name of my variable is has eaten, and that would be true. Let's say I've already eaten today. So this actually gets stored in here. Up here, I've got something called has eaten, and this will be stored as true. So these are the four basic data types that we're going to be using in this class. We'll also use a couple data structures. We'll use lists, and we will also use dictionaries, but strings, integers, floats, and booleans are the four basic data types that we'll be using in this class. So Python 3 has rules for naming, and this includes naming variables. So if I have a variable called address, so that's the label I give it, the name I give it. You'll also see the word identifier. So this is how I'm going to identify the value, and this is going to be a string. And let's say our address is 104 4th Street. So this is a string value. I have it in quotes, and it includes the characters 104 space. Space is a character. It gets stored just like the other characters. 4th space st. So that's the value of my string address. And when we're naming our variables, so like again, address is a name of a variable, in Python 3, we can only use letters, uppercase and lowercase. We can use numbers, and we can use the underscore. So address fits that rule. There's one other rule that we have to remember. Our variable names have to start with a letter. So we've got starts with a letter. It includes all letters. So this is a perfectly acceptable variable name. If I had another variable, maybe called address2, this has all letters and numbers, starts with a letter, so this is going to be a perfectly acceptable variable name. But if I tried to make a variable name and I called it address, tried to assign these some sort of value, this does not fit our rules for variables in Python 3. We can't start our variable names with numbers. We can use the underscore, so we could have something like address_2 is equal to some value. That is completely acceptable. And we could even have something, again, we could have a capital letter. So we could have something like address2 is equal to some value, and this would also be acceptable. However, we can't use anything else in a variable name, and that includes a space. So we could not have something like address space 2. This would not be acceptable. We also can't use any special characters, asterisks, ampersands, plus, minuses. None of those would be acceptable. So in order to be able to have legal names in Python 3, we have to follow these rules. All right, so we talked about the fact that there are variables. We create labels and we assign them values. We can reassign those variables different values. So let's say I have a variable and I call it num1, and that is equal to 29. It is perfectly legal for somewhere else in the program for me to decide that num1 is going to be equal to a new value. So maybe it's going to be equal to 30. Or maybe I'm going to say that num1 is going to be equal to its current value, which is 30 plus 2. So now the value of num1 is going to be 32. So in addition to assigning a value to a variable, we also can reassign that and change the value of that variable over time. In many programming languages, you always have to stick with the same data type. So if num1 starts out as an integer, it has to stay an integer. In Python, however, the Python is not a strictly typed language, so we could actually say that num1 is going to now be equal to some sort of string, and Python will not give us an error. Python will not care that we've done this. Other languages, you would get an error. But in Python, again, and we're going to do this a ton, you're going to start with a value in a variable, and the value of that variable may change over time. If you have a variable that doesn't change over time, so you don't want it to change, like for instance, the value of pi is 3.14159. The value of pi doesn't really change, I guess, unless we wanted to add some more decimal places. But for the most part, you'll have some variables in your programs that don't change value, and we call these constants because their value is going to be constant throughout the program. And we generally put these all in capital letters, the variable names, just so that we have an easy visual to see that it is a constant just by looking at the variable name. So we've been talking about our data types and our data, how we store data in variables, and we have different data types. So we said we've got integers, and these are whole numbers, for example, 29. We have floats. Floats are numbers that contain a fractional portion, a decimal point portion. So this might be something like 2.5. We have strings, which are basically literally whatever is inside the quotes. We have just a string of characters. So we could have something like, I like ice cream because I do, and this includes the letters I, L-I-K-E, I-C-E, C-R-E-A-M, and the spaces in between them. So each of these characters, and this includes the spaces, includes every character in there. If I wanted to put a period at the end, it would also include the period. Each of those are stored in RAM, and so exactly like it is, this holds the string, the character string, inside of RAM for us. Our other data type is a Boolean, our basic data types. And an example of Booleans, well, there's really only two values for Boolean, true and false. And we can also think of true as 1 and false as 0, but these are going to be really useful in a lot of ways, and we'll see later on in the course on how we use these. But an important thing to note about these is that when we create a variable, so let's say we have a variable, we just call it my variable, and it's equal to a 2. So we start with a 2. And then we realize, okay, we've created this variable, we've created it as an integer, but let's say we need it as a string. So data types are not only stored differently, they have different operations that we can do on them. So if you want to subtract and multiply and do mathematical operations on data, you have to have them stored in a numeric data type. So this would be our integers, this would be our floats. We can do different types of things with strings. We have methods for strings that we use to do things like search the string and figure out if we have particular characters inside the string. We can print the string. We can do all different kinds of things, but it has to be a string for us to do those things. So it makes a really big difference what data type you choose in terms of what you can actually do with that data. With the Boolean data, we can test it. We can say, is it true? Is it false? And so you select your data type very carefully for what it actually is that you plan to do with it. But we can actually convert between the data types, and we call this casting. So if you have a variable and is a certain data type, so this is an integer, and let's say we need it as a string, then we can just use a casting function in order to cast it. So we can say what I really want is I want my variable to be the string of 2. And the string str, the parentheses, is actually a function. We're going to learn more about functions, the built-in functions that we can use in Python. But these are the first functions that we're going to see. We're going to see the casting functions. If you want to turn something into a different data type, we have to use a casting function. So for instance, if I had a number, num1 is equal to 29, and I need that to be a float, I can say that num1 is equal to the float of num1. Or I could just put the 29 in there, but this is more generalized. We'll do this more often when we actually use the variable name. So now num1 is storing 29 as a float. So it's going to be stored like this instead of as a whole number. So we can cast things, from integers to floats, from floats to integers. I could not cast this string, I like ice cream, as an integer because clearly there's no integers in here. So we can't convert between everything. Not all values will convert back and forth, especially in the case when you're converting from strings to numbers. But for the most part, we can do conversions. We can convert integers into floats, floats into integers all the time. And if a string holds number characters that will convert into the integer or float data types, then we can also do that conversion as well. So now let's talk about some things that we can do with numerical data. We can perform mathematical operations on numerical data in Python, just like you could do in a calculator or in your head or on a piece of paper for that matter. And we can do all the operations that you're used to, but we may use a slightly different symbol. So we have, of course, multiplication and subtraction, uses the same symbols that you're used to when you're doing on paper. For dividing, we use the / and there is no division sign in Python, so we're always going to be using this / for division. Because the letter X has to represent the letter X, we can't use this for multiplication. So in Python, we use the asterisk. The asterisk is above the number 8, and this is what we always use for multiplication. For exponentiation, you might be used to seeing something like this. Well, we can't kind of make this small little guy, so we're not able to represent it with somehow a smaller character. We don't have that on the keyboard. Some languages will use something like this, but Python does not allow for the little caret character, so neither of these work in Python. What we use in Python is the double asterisk. So that's what we use for exponentiation in Python. And of course, we have our standard parentheses that will allow us to group things together so that we can have them in the correct order, because we have to follow the same order of operation that we learn in our math class. So for instance, exponentiation is going to come before multiplication and division, and that is going to come before addition and subtraction. And of course, even before that comes the parentheses. The parentheses always takes precedence. But in addition to these guys that we have that you may be used to, in Python and in programming, we have some more. You're going to add some new operations to your little toolkit of stuff. They're pretty fun and pretty useful. We have something called floor division. So when you see this double division sign, this is floor division. And what this means is do the division and drop the remainder. We also have this, the percent sign, but the percent sign does not mean percent. It means modulo. And in this case, all you're going to do a division, and you're only going to keep the remainder. So these two complement each other in that in both cases you're doing a division, but here you're dropping the remainder of that division with floor division, and with modulo, you're only keeping the remainder. So let's do an example. So let's say I've got 2 divided into 8. So if I have 2, so in this case, this is going to be 8 floor 2. This goes in evenly. So it's going to be 4. The remainder is 0. 8 floor 2 would be 4, and 8 mod 2 would be 0 because there is no remainder. Let's say instead I have 2 divided into 9. So this looks like this. And if I've got 9 floor 2 and I've got 9 mod 2, all right, well, if I divide 2 into 9, it goes 4 times. We take away the 8, and we have a remainder of 1. So the floor division only cares about how many times it goes into it. So that's going to keep the 4. It drops the remainder, doesn't care at all. Here with modulo, it only cares about the remainder. So the remainder is 1. So 9 mod 2 is equal to 1. So these have the same precedence, the same order of operation as the division and multiplication. And so it just fits right in there that, of course, we're going to do all our parentheses first. Then we're going to do all of our exponents. Then we're going to do our any floor division, modulo, multiplication, division that we have. And then we'll do our addition and subtraction. And of course, if you have more than one of these, we always go from left to right. All right, so we have 2 very useful built-in Python functions that we're going to use right away. And we can think of a function as just kind of a black box. We may send something to the function. We talked about input-output processing, so the function may or may not take some input. Some stuff is going to happen in the function, and then there's going to be some sort of output, something's going to happen as a result of that function. Eventually, we're going to be writing our own functions, but right away, we're going to be using some of the built-in Python functions. And 2 of the most important that we're going to get started with right away are our input functions and our print function. Now, in the model that we're talking about of every computer programming being some sort of input, some sort of process, and some sort of output, these are our methods of input and output to begin with. So when we get started with Python 3, our input is going to come from the keyboard. So that's all we're going to have. We just have keyboard input. We're going to type in some stuff. It's going to come from the keyboard, and then we may do something with that. Something's going to happen in the program, and then all of our output will go onto the computer screen, and that's handled in Python by the print function. So the way the input function works is that we're going to call the input function, and we're usually going to save whatever gets input by the user into some sort of variable. So we might call that variable, for instance, user input. It's great to name variables the thing that they represent. So our user input, and then we have the input function, and what goes inside of the parentheses is a string that's going to be printed to the user to prompt them what to do. So it's called a prompt. It's basically just the directions for the user. So we might say, enter your name. So this is what the computer, Python, is going to show the user. The user will type their name in on the keyboard, and that's going to get saved into the variable name called user input. It's important to know that the input function always returns a string data type in Python. So if we get some user input and we need to do some kind of calculations with it, we're going to have to cast that input as, some sort of number, either an integer or a float, depending on what we're going to be using it for. Our other function is the print function, and this will print to the screen for us. And all we're going to do is put inside of here what we want Python to print. So if we say print hello, Python is just going to print hello to the screen. And we'll see some examples of that when we start using idle and we start actually putting code and running it. So before we get started writing some code and doing some examples, we need to talk about errors that we're going to see when we're programming. So errors fall basically into 3 categories. we have syntax errors, we have runtime errors, and we have logic errors. So syntax errors refers to the kind of errors that make it so the program doesn't run at all. So this would be, for instance, we have to be pretty precise when we do Python. So let's say we did the print function and we forgot the closing parentheses. This would be a syntax error. The program wouldn't run at all. You would just immediately get an error. We could misspell print. And maybe the parentheses are right, but this is misspelled. It's looking for print, P-R-I-N-T, all lowercase. If we misspell that or we use an uppercase P, that's going to be a syntax error. The Python interpreter that runs the program for us, that basically takes our statements and turns them into machine code that the computer can understand, can't understand this. So the program is basically not understandable to the computer. The computer doesn't understand your syntax, so the program doesn't even run. A runtime error means everything's starting out okay and the syntax is correct, but you ask the computer to do something it isn't capable of doing. For instance, dividing by 0. This is an undefined operation. The computer's not going to see that as a syntax error as long as, let's say we said x equals 5 divided by 0. Python's going to say that looks good to me. It's going to try to run the program, and then while the program is running, you've asked it to do something that isn't possible. So that's a runtime error. The logic errors, these may also be called semantic errors. You might see that vocabulary. The computer doesn't actually care about these at all. Humans care about these. So this would be something like, let's say you were supposed to multiply and instead you divided. This is going to be fine. The computer is going to give you the answer, but it's going to be the wrong answer. So the computer doesn't care at all about logic errors. Everything runs just fine. But when you look at your output, it's not logical. It doesn't make any sense to the humans. So these are the two errors that will cause a crash. A syntax error, it crashes before it even runs. Runtime, it can run, but you're going to crash in the middle of the program. These are usually a little bit easier to spot and a little bit easier to debug because it's very clear that an error has happened. Your program broke. Logic and semantic errors, you have to make sure that you're double checking those because the program is going to run just fine. You just have to make sure that you didn't make an error in logic. That means you got the incorrect answer even though the program worked.